Okay, we're going to continue Chapter 10, Section 3, and in this particular section, it's all about equations in what we call quadratic form. These are going to be equations that are not originally quadratics, but after a little bit of algebraic manipulations, they will turn into quadratics, and then we can use any of our three ways of solving quadratics, which of course, once again, is factoring, square root method, or of course the quadratic formula. But the first thing that we have to do is get our equations into quadratic form. And we saw problems like this already in chapters 8 and 9. You may recall in chapter 8, we dealt with rational equations. For example, we may have 10 over x minus 7 over x plus 1 equals 2/3. Now this is a rational equation, and you may recall when we solved rational equations in chapter 8, it was a 6-step process, and step 1 is already done for us because the denominators are already factored. Step 2, we have to identify restrictions, and so x can't equal 0 because of the first fraction, as well as x can't equal a -1 because of our second fraction. And so now let's see what we have to do here. We are going to now multiply by the lowest common denominator, which happens to be a 3x times x plus 1. That's the lowest common denominator. If I multiply this first fraction with the lowest common denominator, we are in fact left with a 30 times x plus 1. Then there's the minus sign. If I multiply the second fraction with the lowest common denominator, what remains is a 7 times 3x equals. Finally, now we would have to multiply the lowest common denominator with the 2/3. And in doing so, we would have a 2x times an x plus 1 remaining. So as promised, no more fractions to contend with. So now let's see what we're going to have to do. I will distribute my 30. I will distribute the -7, as well as I will have to distribute my 2x. And when we do that, we get a 30x plus 30 minus a 21x equals 2x squared plus 2x. And right here, we have now formed a quadratic equation. Originally, it was a rational equation, but now, using some algebraic manipulations, we formed a quadratic. Well, in order for us to solve this quadratic, we need to simplify and get one side equal to 0. And so I'm going to combine my like terms here on the left side. 30 minus the 21x, that of course would give us a 9x plus 30 equals the 2x squared plus 2x. I'm going to get one side equal to 0. I'm going to subtract the 9x over, as well as subtract the 30 over. That would give me now 2x squared. The 2 minus the 9, of course, that would give us a -7x minus 30. This is going to equal 0. And it's at this point we have a choice. We can solve this by either factoring, or we can use the quadratic formula. Square root method doesn't apply because of the linear x term in the middle. Well, this is factorable, so I might consider factoring it. Factors of 2x squared, 2x and x. We know we need different signs, and so let's see, we would need to have a -6 as well as a +5 as our factored form of the trinomial. Zero product property. Now that we can solve this quadratic equation, we would in fact get x equals a -5/2 and x equals 6. Neither solutions conflict with our restrictions from step 2. So we have found our 2 solutions to this rational equation. Now, it was rational originally, but remember, we turned it into a quadratic equation, and that's what we saw in chapter 8. In chapter 9, remember, it was all about radicals. So when we were solving radical equations, such as maybe x plus the square root of x equals 12. Remember, this was a 4-step process. Step 1 was to isolate the radical, which means I would have to subtract x over. Step 2, we want to eliminate the radical, so I will square both sides. And when we square the left, we get just x. And if I square the right side, and I write it in descending order of terms, as we like to do, would give us an x squared, a minus 24x, and a plus 144. And once again, what did we form? We went from a radical equation to a quadratic equation. And so now we have to get one side equal to 0. So I'm going to subtract the x over. And that would now give us x squared minus 25x plus 144 equals 0. Well, now we have to solve this. Once again, we could either use factoring or we could use the quadratic formula. The one method that does not apply, once again, is that square root method. Well, this is factorable, so let me factor it down. And let's see what we have going on here. The factors of x squared, of course, would be x and x. We know we're dealing with the same sign, 2 negatives. And what 2 numbers multiply to a positive 144 and add up to a negative 25? Well, that would be a negative 16 and a negative 9. And so now, let's go and take a look. Zero product property would indicate that x equals 16 and x equals the positive 9. But remember, there is a 4th step to solving radical equations, and we would want to check to make sure that both solutions work. And you would find that actually the 16, when you were substituted back in, is extraneous. It's an extra solution. It is a solution to the quadratic equation. However, it is not a solution to our radical equation. So our only solution would be the positive 9. So that's a little review of solving equations in quadratic form, stuff that we saw in chapters 8 and 9. But let's take a look at something a little bit different here in chapter 10. Once again, the equation that you're going to be given is not originally a quadratic equation, but what we're going to do is we are going to turn it into a quadratic equation to make it a little bit easier for us to solve. For example, let's say we have x to the 4th power minus 10x squared plus 9 equals 0. Now, this is not actually a quadratic equation. This is technically called a quartic equation because the exponent, the largest exponent, is a degree of 4, and that's what makes it a quartic equation, not a quadratic. But what we're going to do is we're going to use a little substitution, okay? I want you to think about your laws of exponents for a moment. That goes back a ways. This x to the 4th power, that is the same thing as x squared squared. Because power to a power, we would have to multiply those powers. So all I'm going to do is I'm going to rewrite the first term. Instead of x to the 4th power, I'm going to think of it as my x squared term power being squared. I'm going to write everything else the same. So we're going to have still a minus 10x squared plus 9 equals 0. And here's what I'm going to do. I'm going to use a little substitution. I am going to replace x squared. Okay, wherever I see an x squared in my equation, I'm going to replace it with a much simpler variable. Any variable you pick. I'll pick, let's say, the variable n. So if I see an x squared in my equation, I will now replace it with a singular variable of n. And now let's take a look at the equation. I have an x squared here, and I have an x squared here. So if ever there's an x squared, just put an n in its place. And that would now give me n squared minus 10n plus 9 equals 0. And what did we just do? Okay, we replaced this x squared with the n. This squared is from here. Then we have just the 10 times n plus the 9. And now we have formed a quadratic equation. Now what we can do is we can solve this quadratic equation. And this happens to be nice and factorable. So let's factor it down. Factors of n squared, n and n. We know our signs are going to be the same, two negative numbers. And factors now of 9 that add up to 10 would have to be 1 and 9. And solving now for n. That's what we would have to do next. Solve for n. In which case we would get n equals 1 and n equals 9. But hold up, we're not done, because we wanted to, in the original equation, solve for x. And we already now only solved for n. But remember what we did up here. We had stipulated, we created the fact that the relationship between x squared is that it equals n. And since we know what n is, we could now say that x squared equals 1 and x squared equals the number 9. And now we can actually go and use the square root method to solve this particular equation. Because I'm going to take the square root of both sides, and that would give me x equals plus or minus the number 1. And then if I go and take the square root of both sides of the second part, we would get x equals plus or minus the number 3. So now we have 4 solutions for x, the original equation. Positive 1, negative 1, positive 3, negative 3. Okay? So here, once again, what did we do? We took the quadratic equation, we used a little substitution technique, and we turned it into a quadratic equation, something a bit more familiar to us. And then we used techniques of the quadratic equation to solve for this new variable n. Once we solved for n, you have to go back and solve for the original variable x. Let's do another similar type problem. Let's say we have x to the 4th plus x squared minus 12 equals 0. Once again, this is a quadratic equation. And to solve this, once again, think of the first term, x to the 4th, as simply x squared squared, plus the second term, x squared, minus the third term, 12 equals 0. And once again, wherever I see x squared, I'm going to simplify it with a singular variable. Once again, I'll pick the variable n. You could pick any variable you want, just don't pick x. And so now, wherever I see the x squared, I replace it with the n. So now I'm just going to simply have n squared plus n minus 12 equals 0. So once again, we went from a quadratic equation to a quadratic equation. Now we want to solve this. To solve the quadratic equation, once again, any method would work except square root method. I'm going to factor this. It's nice and factorable. Factors of n squared and an n. Different signs now, and the factors of a negative 12 that would add up to a positive 1 would of course have to be, oops, jumped there, would have to be a positive 4 and a negative 3. Solving now for n, we get n equals a negative 4 and n equals 3. But the original equation is in terms of the variable x, and that's what we have to solve for. And since we established earlier the relationship that x squared equals n, we can now say that x squared equals negative 4, as well as x squared equals the positive 3. And so now we want to go and solve for the variable x, and once again we can use the square root method. I'm going to go and simply take the square root of the left side plus minus the square root of the right. When we take the square root of x squared, we get just x, but watch out now, we have plus or minus, and of course we know that the square root of a negative 4 is going to involve that imaginary unit, and we get a 2i. So here we have two solutions, and so now here in the second equation, if x squared equals 3, I'm going to go and take the square root of both sides, in which case now we get x equals plus or minus the square root of 3. So now once again we have 4 solutions. 2 of them are real, square root of 3 and negative square root of 3. Those are real numbers. 2 of them are imaginaries, positive 2i and a negative 2i. Okay. Let's take a look at something just a little bit different. Same concept though, okay? Where once again we're going to turn an equation into a quadratic equation. And so let's say we have the following. X to the 2/3 power plus x to the 1/3 power minus 6 equals 0. Now this equation is a little bit different than what we are really used to because it's just involving fractional exponents. But we are going to do something similar that we did in the previous 2 problems, in that this first term, x to the 2/3, can be thought of as x to the 1/3 squared. Because, once again, the law of exponents, if we have an exponent raised to another exponent, we would multiply those 2 powers, and if you multiply a third times 2, you would get 2/3. Plus, we still have x to the 1/3 power minus 6 equals 0. And now, once again, we're going to have to use a little substitution in that wherever we see x to the 1/3 power, I'm going to set that equal to any variable of choice. Once again, I'm a creature of habit. I'm going to let my variable be n. And so now let's see what we can do here. Wherever I see x to the 1/3, I'm simply going to put in the variable n. So here's an x to the 1/3. That means I'm just going to have n squared. Plus, here's an x to the 1/3, just the variable n, minus 6 equals 0. Once again, this is nice and factorable, okay? In which case I would solve this by factoring. The factors of n squared, n and n. And then let's see what we can do here. Different signs, plus and a minus. And what factors of a negative 6 add up to a positive 1? That would be a 3 and a negative 2. In which case now we get n equals negative 3 and n equals a positive 2. But one more thing we have to do. The original equation is in terms of the variable x. So we have to now go and find out what x is. Since we established the relationship that x to the 1/3 power equals n, we of course can now say x to the 1/3 power equals a negative 3, and x to the 1/3 power equals a positive 2. Well, to get rid of this fractional exponent, okay, of 1/3, what you want to do is you want to raise both sides to the reciprocal power, and the reciprocal of 1/3 is 3. So we're going to cube both sides. Same thing here. X to the 1/3 power, we want to eliminate that 1/3 power. So I'm going to raise both sides to the reciprocal power, the power of 3. Power to a power, law of exponents tells us to multiply, and 1/3 of 3 is just x. Negative 3 to the 3rd power, be careful now, that's a negative 27. That's one solution. Here, x to the 1/3 cubed, power to a power, you multiply, giving us just x equals 2 to the 3rd power. 2 cubed, of course, is the number 8. So here we have two solutions to this equation. A little bit different involving the fractional exponents, but not impossible. One more problem to show you. Let's say, for example, we had 2 times 3x plus 1 squared minus 7 times 3x plus 1 minus 4 equals 0. Now, we're going to use the same substitution technique that we used in the previous problems, okay? Because let's take a look at this equation real closely. And there's something I notice here that this equation has in common to the first and the second term. And the first and the second term both have this common 3x plus 1. So here's what I'm going to do. Wherever I see the 3x plus 1, I am going to replace it once again with a much simpler variable, any variable of your choice. Once again, I'm going to pick the variable n. And so this first term, instead of 2 times 3x plus 1 squared, would now just become 2 times n squared. This second term, instead of negative 7 times the 3x plus 1, would simply become a minus 7n. Minus 4 equals 0. And now we can see here that once again we went from a much more complicated equation to a much easier, simpler quadratic equation. And once again, we could use any method of choice in terms of how we want to solve this particular equation. Well, you know what? We haven't used the quadratic formula today, so let's maybe use the quadratic formula. A is going to equal 2, B will equal a negative 7, C would be equal to a negative 4. In which case, if we recall the formula, in this particular case we're using n is going to equal the opposite of b, which is 7, plus or minus square root b squared, or 49, minus 4 times a, which we know to be 2, times c is the negative 4, all divided by 2 times a, which is still 2. Well, let's simplify this. So we still have 7 plus or minus. Now let's see what we can do underneath that radical. Well, if we simplify by taking 49 minus 4 times 2 times the negative 4, we get 81. Over, in the denominator, 2 times 2, or simply 4. In which case now n is going to equal 7 plus or minus. If we take the square root of 81, we get 9 over 4. So of course now n equals 7 plus 9 over 4, as well as n is going to equal 7 minus 9 over 4. Well, let's simplify what we can. Excuse me, 7 plus 9, that would be 16, divided by 4 is 4. And then if we were to take 7 minus 9, that would give us a negative 2 divided by 4. That would give us a negative 1/2. Now that is what n equals. These are the values of n. But remember, the original equation is asking us to solve for x. And we established earlier that there is a relationship here between 3x plus 1, how it equals n. In which case now, we would be able to say that 3x plus 1 is going to equal 4, as well as 3x plus 1 will have to equal the negative 1/2. Those are the two values of n. Well, now let's go and solve. I'll start by subtracting 1. That would give us a 3x equals 3, x equals 1. That's one solution. Over here, let's subtract 1 from both sides. That would give us a 3x equals to a negative 3/2. And then if we go and divide both sides by 3, or multiply both sides by a third, we would get x equals a negative 1/2. Those are your two solutions for that particular equation. Okay, so that was section 10.3. Once again, 10.3 was all about turning equations that were originally a different type of equation into a simpler, more familiar quadratic. Okay, once you get it into a quadratic equation, then you could use any method that you choose to solve that quadratic equation. You want to make sure that you are solving for the original variable. Okay, in a lot of these problems, we used a substitution of n, okay, or any variable of your choice, but you must always solve for the original equation of the problem. Of course, there's some homework problems that go along with this. Give it a shot and see how you make out. Talk to you soon.